So I'm going to talk about building images for the secure supply chain. I'm actually no longer product manager. I'm actually in DevRel now, or Technical Community Advocate, I think is my official title. So I work for Chainguard, and we do software supply chain security. I'm going to be mainly talking about vulnerabilities and so on in this talk. But first, I wanted to kind of wake everybody up. So we're going to have a quiz. You all look super happy about this. Don't worry, there's only 2 or 3 questions. Most of you are probably aware that vulnerabilities are given a CVE number. So for example, Heartbleed, the OpenSSL vulnerability, was CVE 2014-0160. So I'm going to give you some CVE numbers, and I want you to tell me what they are. So feel free to shout out if you know. So the CVE 2017-5638. This is probably the hardest question. Does anybody know what application framework this vulnerability was in? Any guesses? Okay. Pardon? OpenSSL? That's a very good guess, but it's not right. It's actually Apache struts. So this was a remote code execution in Apache struts, which most of you are probably aware is a Java MVC framework. And it actually allowed complete remote code execution via HTTP headers. So all an attacker had to do was craft a malicious HTTP header, and they could run code on your server. The main reason I mention this is because this was a factor in the Equifax data breach, which was an enormous data breach. There's 150 million US citizens and 15 million UK citizens, plus a smaller number in Canada. All their sort of financial data on Equifax was compromised. So it was pretty bad. And I believe it's still one of the largest data breaches in history. Now, the CVE was a 0-day. But by the time Equifax was hacked, there had been a patch available for around 5 days. So I admit it was tight, but it is possible they could have updated their systems and avoided this issue. Okay, next one. Is this one Log4j? I got 2. I don't think this one is Log4j, because Log4j was earlier. But good guess. Any other guesses? Can you tell me? Yeah, this is actually one that was important enough to get its own name. It was just last year. Sorry? No. That was the year before. You've all got short memories. Well, actually, you've got short memory, you should remember this, but it was in the Linux kernel. Anyone? No. It was big enough to get its own name. It was Dirty Pipe. I don't know if any of you saw that one. It was pretty serious because it was somewhat mitigated because it's fairly complex to exploit, but it did allow an unprivileged user to basically write to any file. So in one of the exploits, they write like to the SSH directory so they can SSH in as root. So you could do clever things and use this for privilege escalation. So it's a very serious vulnerability. And one of the things was Android devices were affected, or are affected, so probably a bunch of them are unpatched. So a bunch of people's mobile phones are at risk because of this. And Dirty Pipe was named after Dirty Cow. Do people remember Dirty Cow? That was from 2016, and that was a copy and write attack. And if you go back and look at that, you'll find that there was dozens of hundreds of malicious Android applications released that attack this vulnerability, or the Dirty Cow vulnerability. Okay, last one. You've actually already named this one. Yay! Log4j. 1 out of 3 ain't bad. Or Log4Shell, but it was a vulnerability in Log4j. Yeah, so this has been called the single biggest, most critical vulnerability ever, which is a pretty bold statement. The Log4j software was and is so prevalent that nearly all large organizations were running it somewhere, whether they knew it or not. And so millions of ops and security staff across thousands of organizations had a really bad week trying to deal with this and mitigate or find and mitigate all the instances of Log4j in their systems. And millions of devices were affected because it also affected IoT stuff like TVs and so on. They'd all turned out to be running Log4j somewhere. So my point of all this is that vulnerabilities are bad. They end up getting you hacked. And they cost organizations millions, whether it's in reputational damage and reputational loss, or directly in lawsuits, or just in ransomware when everything gets crypto-locked. Okay, so in this talk, I'm going to be talking about vulnerabilities and how they relate to containers and container images. I'm guessing most of you have used containers for a certain length of time, and how many of you have tried like a vulnerability scanner such as Aqua, Trivy, Gripe, or Sneak or something? Yeah, even if you just run it like locally, have most of you sort of come across them? Cool. So vulnerability scanners, take an image, they'll try and make a list of all the software inside that image and the versions of that software. And then they compare that list to various security databases. And as a result, you get a list of what the scanner believes are possible vulnerabilities in that container image. And this sounds fantastic, right? Because ideally, what I would do is I run a scanner on my image, if it finds any vulnerabilities, well, I'm not going to put that in production because it's vulnerable. But yeah, that was the sort of naive hope. Most of you have run a vulnerability scanner, so you're probably aware there's a bit of a problem. And the problem is this. If you run basically any vulnerability scanner on the official images or base images or whatever, you nearly always find vulnerabilities. And sometimes you find quite a lot of vulnerabilities. So you're immediately overwhelmed with all these vulnerabilities that you can't really deal with, which sort of negates a lot of the use of the vulnerability scanner. So this example, I ran this morning. So yeah, if you run it again now, you should get exactly the same result. So today in Nginx, we have 151 packages and 86 vulnerabilities. None critical, thankfully, but apparently 3 are high. There's 2 fixed. I'll explain what fixed is later. But then we run Node. Node's kind of infamous for having lots of vulnerabilities. It's actually got a lot better recently. I'm not quite sure why. Because I ran this morning, and there is 658 vulnerabilities. That's not a mistake. Gripe says there are 658 vulnerabilities. I did run it twice. I did make sure Gripe was updated, and I did make sure I had the latest version of Node. So that is the correct result. It's actually much better than it was like a week or 2 ago when I ran it, and it got over 1,000 vulnerabilities. That may have been a mistake in Gripe. I'm not 100% sure. But anyway, you're kind of swimming in vulnerabilities. And the problem is, there's so much that's hard to even use these tools because you're starting from a point of dealing with all these vulnerabilities. And a lot of people seem to get to the stage and give up, or at least end up with suboptimal results. So I've heard stories like security teams trying to investigate all vulnerabilities, and when they find vulnerabilities, the images are sent back to the developers with instructions to either fix them or come up with a reason why they can't be exploited. Then there's platform teams who provide base images to application teams and so on, but the very base image they're providing is full of vulnerabilities to the point that nobody notices when the application team accidentally adds some vulnerabilities. And then there's teams that spend so long investigating vulnerabilities that by the time they've mitigated them, there's a dozen new vulnerabilities to deal with. So it's really not a great state at the minute. But I do have a solution. And as an example, I'm going to walk through the Redis image. Now, these scans, they're not from today. I think I did scan this earlier today. Do I have the results? Yeah, I did scan this earlier today, and there's now 2 critical and 20 high, I believe. So they fixed one of the critical vulnerabilities. But this is what you get when you scan the default Redis image from the Docker Hub. Now, most of you are probably aware that the default images are based on Debian. Like if you don't specify a variant, you get Debian by default. And that just comes with a whole bunch of packages. In this case, you know, we've got 100 packages. Some of those will be Redis or related to Redis. But most of it's just related to Debian and the base image itself. And in that, we have 84 vulnerabilities and 3 critical. I believe now it's 2 and 20. Now, we can do a lot better. If we look at the Alpine version, suddenly there's only 20 packages. Now, it's not fair to directly compare Alpine and Debian, but basically Alpine is a much smaller Linux distribution. And that's basically why there's less vulnerabilities. It's just less to have a vulnerability in. But in this scan, I still found 2 critical, 2 high, and 1 low. I believe this is slightly different now. I think 2 of them are gone if you scan again this morning. And it actually relates to, you see these 2 fixed. And again, I'll explain why that's the case in a moment. So this is the only image that has exactly the same results 2 weeks ago and today. So at Chainguard, we publish our own images. You can go and pull the latest versions and play with them and run your own scans and see what it says. But yeah, you can see there's roughly the same number of packages in our version as the Alpine version, but now there's 0 vulnerabilities. So one of the key points of this talk is that it is possible to get to 0 vulnerabilities. And there's no special sauce. Like we've not, I swear to you, we've not cheated. And actually, the way we did it is fairly simple. There's kind of 3 points, 3 main techniques that we're using. The first one is cut down dependencies. There's less in the image, there's less to have a vulnerability. Second point is keep things as up to date as possible. You know, apply updates and patches as quickly as you can. And the third point gets into patching things yourself and also security advisories that I'll talk about a bit more. So, cutting down dependencies. So if you go back to the Redis example, we saw there's 100 packages in Debian, but only 20 in Alpine, and only 19 in Wolfi, which is the Chainguard Linux distribution we use. And yeah, so this just comes down to complexity and reducing the amount of stuff in the container. All these images do pretty much the same thing. Like, I think you'll be hard-pressed to find a difference between running Redis in the Debian image and the Alpine and Wolfi images. That being said, do be aware that Alpine is a muzzle-based distro, so it does use this different standard C library for talking to the kernel. And that can have implications in some cases. Wolfi and Debian, though, are both glibc. And yeah, so there's a bunch of software in that container that is not, or in the Debian container at least, that is not required to run Redis. Okay, this point about keeping things up to date. If you look at the Alpine and Debian Linux distributions, there's a bunch of steps that we have to go through from a vulnerability being announced through to getting it fixed in a container image. So after a vulnerability is found, hopefully there might already be a patch before it's announced, depending if it's a 0-day or not. But after the upstream releases a patch, you have to wait for the distribution, like Alpine or Debian, to pick up that patch and create a new package with that patch inside it. And then once that's happened, you have to wait for Docker or whoever is creating the image to create a new version of the image with a new version of that package inside it. And from my own non-scientific research, it seems that this takes around 1 to 2 weeks. And that is one of the reasons that Chainguard, we created our own Linux distribution called Wolfi. We called it Wolfi because everything at Chainguard is sort of octopus-based, and Wolfi is the smallest octopus. So it's nothing to do with wolves, it's actually to do with octopi, or octopuses, or whatever the plural is. Cephalopods. So what makes Wolfi different? Why did we create Wolfi rather than use something that was already there? First thing to point out, we sometimes call Wolfi an undistro. It's not really a full Linux distribution because we don't ship the kernel. Most of you are probably aware how containers work, and you actually use, when you run Docker run, you're using the kernel from the host, or you're using the kernel from a VM. But the container itself doesn't have the kernel inside it. So in Wolfi, there's no kernel. It's really just a package repository full of packages that we've compiled from source. And that's why we call it undistro. There are some similarities to Alpine because we use the apk packaging format, which is created by Alpine. However, unlike Alpine, who compiled everything against Muzzle, we've compiled everything from source against glibc. And there's actually a really cool blog recently about how we went back and compiled Java from source and bootstrapped them from really old versions of Java to get to the modern versions that you can look up. Wolfi is a rolling distribution. We don't do point releases. There's no like Wolfi equivalent of SID or any sort of point in time. You're always sort of on the latest version of things. All our packages come with SBOMs, or software bill of materials. I'm not going to talk about that too much in this talk, but I really think that's going to be something very important in the future. Basically, an SBOM tells you what software is in a package and the versions. And hopefully, it'll also tell you about transitive dependencies. Maybe it'll even tell you about build time stuff as well. At the minute, we're very much focused on ARC64 and x86-64, so ARM chips and Intel chips. Some of our images are available for a few other architectures, and hopefully we'll have more architectures in the future. But I mean, this is 99% of what everybody runs. We also have some of our own build tooling. So to create Wolfi APK packages, we use Melange. And to create our container images for Chainguard, we use a tool called apko. So we don't use Docker build. We actually use a much simpler tool called apko. It can't do everything that Docker build can do. All apko really does is take a list of APKs and compile them into an image. And because it's simpler, it's also more, or it's much easier to make it reproducible. So if you run apko twice, you'll get sort of the same tarball out, down to the binary level, which is actually something relatively hard to do in Docker. You have to try and control timestamps and build IDs and things like that, but that kind of comes out of the box with apko. It's also declarative YAML. Everybody loves YAML. And one of the big advantages of having our own Linux distribution is that we can get this 1 to 2 week cycle down to minutes or hours. So if a new patch or new vulnerability drops, we can pull in a patch for that. We can rebuild the package it corresponds to. And we can rebuild any image that uses that package within a matter of minutes or hours, which is a huge advantage over being tied to Alpine or Debian for building our images. Okay, so here's the point where things get a little bit complex. Keeping things up to date and reducing dependencies does account for 90% of the work we do, but there's still always a few CVEs that we have to deal with, that the scanners turn up. One reason, and so sometimes we have to apply patches ourselves. For example, the example here I've got, say you have an upstream project, like we'll call it food project, and food project is dependent on bar project. Now there's a vulnerability in bar project, but it's not in food project. So food project might not do a new release to update bar project for a while. But we need to update it ourselves so to resolve that vulnerability. So we might be shipping a new version of food project with a new version of the bar project inside it, but we're really still on the version of the code that the upstream release, say it's 1.27 or whatever. So we need a way to tell the scanners, hey, okay, we're on version 1.27 of food project, but we have fixed this vulnerability. Our version is not vulnerable to this CVE. And the way you tell scanners that is through something called a security advisory. So if we go back to Alpine Redis vulnerabilities, these top two are now gone. But when I ran this scan a few weeks ago, the top two turned up. And so the top two are kind of interesting because you'll see it says fixed in. And so what this means is the Docker image had version 3.10 of the libSSL3 installed, but there was actually already a version of Alpine with 3.11, or Alpine had already released version 3.11 of the package, which addressed this high vulnerability. But it took a few days or week or so before the new Docker image was created with the new version of this package. And at the time I ran this scan, that hadn't happened. It has now. But there's still 3 other vulnerabilities. So why do those turn up in the Alpine image, but not in the Wolfi image? It's kind of interesting, right? And the answer lies in security advisories. So you can go today and check out the advisory for Wolfi. It's just at wolfi-dev. So all the Wolfi stuff's at wolfi-dev. And yeah, you can go to that URL and you can see the advisories for all our packages. And this is what it kind of looks like. It's just a bunch of YAML. It's really quite simple. Here's the one for Redis. I've only got the very top of the file here. And you can see we mentioned CVE 2022-0543, and we're saying this has been fixed since version 7.07, which is actually quite a while. And if we go back, we can see this is this is a critical vulnerability listed here. So the reason it doesn't turn up when in the Chainguard images, because Gripe knows to go and check our advisory and says, okay, they're saying that doesn't exist. And I even went and looked at this CVE, and it actually turns out to be something to do with Debian packaging. So I'm 100% sure that Alpine is not vulnerable to this CVE. So why is it showing up? And the reason is the Docker build does not install Redis from Alpine. The Docker build actually goes and gets Redis from the Redis server and compiles it and installs it itself. So the scanner can't go to Alpine and say, hey, you know, what CVEs are fixed in this Redis, because it's not the Redis from Alpine. So there's nowhere for the scanner to go and say, hey, what's the vulnerabilities in this? So it's just kind of assuming these vulnerabilities exist because it knows there's a CVE related to this version of Redis and nobody's told it it's fixed. So with those 3 points, reducing dependencies, keeping stuff up to date, and security advisories for the rest is how we get to absolutely 0 vulnerabilities in our Chainguard images. But you're probably thinking, okay, that's great for Chainguard, but what about myself? How do I run containers with 0 vulnerabilities? And the answer is pretty much the same. The glib answer is use our images, because we do have images for a bunch of applications, like Nginx, Redis, Vault, blah, blah, blah. You can get a full list on GitHub or on our website. Let me grab some water. Do I have water? Down there. I'll go for a walk. Sorry. Probably the easiest, the most low-hanging fruit thing you can do today is just use a smaller base image. I mean, you saw earlier how many vulnerabilities were in Debian compared to Alpine. There's also something called Debian Slim. So if you're using Debian base images at the minute, try something called Debian Slim. It's really just Debian with a bunch of packages removed. So you can probably just switch that and you'll save yourself a few vulnerabilities. Likewise, Alpine, if you can probably try changing to Alpine. there might be some functional differences in there because of the change from glibc to muzzle. Do be aware of that, but Alpine's great. I would recommend trying it. Scratch is the completely empty Docker image, which you can use in some cases, and I'm going to talk about that and how that leads into Google Distroless and the Chainguard approach to base images. So Scratch is the completely empty image. There's nothing in it at all. So it sounds quite useless, but in fact, it is pretty cool. You can do things with it, especially if you use a compiled language like Go or Rust or C, because you can create something called a static binary with all the dependencies inside it. And you can take that static binary, you can put it in the completely empty image and run it. And then you've got the most minimal possible image. Well, assuming you've not compiled too many dependencies in. But that is like, the best you can do. It's fantastic. But what you'll actually find is you can't do that with a lot of applications, because generally applications expect some operating system stuff to be available. The most common one's probably CA certificates. If you want to talk to a TLS server or over HTTPS or whatever, you're going to need CA certificates. Also, time zone data, that's needed quite a lot. Directory layout, a lot of stuff expects like /etc or /temp, for example. So you kind of want standard Linux directories to be available. And users is another common one. People expect 1 or 2 users to be available. And that's exactly why Google created the Distroless project. So Distroless is a really, really stripped down version of Debian. Like there's almost nothing in it. Yeah, it's much smaller than Debian, and it's actually even smaller than Alpine if you're looking at the static base image. And they've taken it so far that there's not even a package manager or shell in that image. So it's really just for copying a binary in or an application in and running it. It's for production, it's not really for development or anything. They do have images for like a static base image or static binaries. There's also ones for Java and Python, I believe. I can't remember for other variants, but it's a very limited number. The biggest problem with Google Distroless is it's a bit difficult to extend. So you might be in the case, you might think, well, I want this image, but I want one more Debian package in it because I need that for my application. And that sounds reasonable, should be something easy to do, but it's not really, because you're going to have to play with Bazel or Bazel or whatever you call it. I don't know if any of you have tried Bazel, but it's not necessarily, somebody's laughing, it's not really a lot of fun, I'm going to tell you that. It's really meant for big infrastructure projects. So that takes us to Chainguard base images. Very similar philosophy and approach to Google Distroless, which is unsurprising given the people that founded Chainguard were actually on the Google Distroless project as well. However, unlike Google Distroless, hopefully our images are a lot easier to extend and customize. You can use apko, which is our own build tool, to create new images, but you can also just use a Docker file. If you use a Docker file, you probably want to use the -dev variant, which will add in a shell and package manager to our images. We have SBOMs, which are pulled through from Wolfi, so you should get a complete analysis of all the software in the image. Yeah, our images are updated every day. You might notice we rebuild all images every day, but the date build stamp may be a few days old, and what that indicates is there's been no changes. Like, although we've rebuilt it, it hasn't changed in the last few days. And again, it's all based on glibc. Yeah, the next thing you want to think about doing is cutting down dependencies. So there's a few things you can do here. Most people have probably tried multi-stage builds. That's where you do a compilation and build your software in one container, and then you copy the result into another image. So your production image doesn't have all your build artifacts in it, it just has the final thing. And that leads nicely into development and debug dependencies, so you don't want those things in your production image. Have a separate dev or debug variant for that kind of thing. The other thing I would say is, in actual application development, try to pull in less libraries. This is a lot easier said than done, I realize. But do think about whether you really need that library for one function call, or if there's another way you can do it. Because when you pull in a library, you're pulling in a lot of risk, effectively. And you have to keep that library up to date, or it's going to get vulnerabilities and so on. Yeah, you don't want to be in the, what was it, JavaScript left pad. That's exactly the sort of thing you do not want to happen. The final point I want to talk about is just keeping updated. I actually think this is probably the hardest thing, because I think we're all aware you update something and everything breaks, right? And that's why organizations have a lot of scar tissue and they're scared to keep things up to date and live on the bleeding edge. And that makes sense. What I would say is it's better to keep things updated and run tests to catch as much as possible than it is to end up being Equifax. There are tools you can get to help you here. Stuff like Dependabot, I think a lot of you have probably seen, that'll look at, that runs in GitHub and tells you when you need to update a library, for example. I mentioned earlier, I work with a bunch of people from Google, and they introduced this concept of build horizon to me, which I hadn't heard before and I thought was quite interesting. Basically, apparently at Google, say a container or a VM or some service has been running continuously for a period of time. I think it's even as short as a week. Even if there's no updates to the code for that service, they will replace that service with a fresh version. The reason being that, of course, there might be updates to other software dependencies or the operating system and so on. So you don't actually want a service that's been running for 200 days in production. I think we used to use it as a stamp of reliability, but you can also see it as a stamp of, hey, there's probably vulnerabilities in this. Okay, so that's pretty much what I want to talk about. The big summary is use better images, and you can totally go and look at the Chainguard ones, but also even just using Alpine or a smaller base image will get you a long way. Reduce your images, dependencies, be really aggressive about that. That will get you a long way as well. The hardest point, keep everything up to date. Like, run tests on everything and update everything. That is the difficult part, but that's what will prevent you getting hacked. And if you do all those things, you too can get to 0 vulnerabilities. Okay, thank you all.